So what I'm going to try to focus on instead of that is whether or not consciousness emerges. I heard that this was related to the last couple of talks, but I was actually teaching on Zoom for the last couple of hours, so I wasn't here. But feel free to bring up anything that's relevant in Q&A about those talks. My background, for people who are not familiar with my work, is in attention. What I have argued in my work is that there is a subject, a natural subject, a brain-based account of a subject, and I make an account for that subject through work on attention. So that's where I'm coming from, and I take it that the subject emerges, and that's something that I argue for in my work. So I'm not against emergence as a concept. I'm not against the idea that some things in the natural world emerge. I just don't think consciousness emerges. So my answer to this question is no, and you'll see why. You might be tempted to think that consciousness is the thing that's the most likely to emerge of all things. I think that perspective is very widely shared. You'll see it come up in a lot of papers on consciousness. Edelman, back in 2003, wrote that consciousness is not a thing, but rather, as William James pointed out, a process that emerges from interactions of the brain, the body, and the environment. Wolfsinger says that brain states that are compatible with the manifestation of consciousness favor the emergence of ordered spatiotemporal activity patterns that could serve as substrate for the formation of assemblies. By contrast, the response properties of individual neurons tend to differ only little in awake, sleeping, and anesthetized brains. Herzog et al., in this small network argument about consciousness, say that consciousness emerges when attention and planning come into play, and they contrast the automatic unconscious mode with a mode using attention where consciousness emerges. Global workspace theory is also connected to this concept of emergence. Often the word emergence is used loosely, like how does a serial, integrated, and very limited stream of consciousness emerge from a nervous system that is mostly unconscious, distributed, parallel, and of enormous capacity. Even though the word is used loosely, I think this concept is very important to global workspace theory. But today I'll be focusing mostly on this paper, on whether there's causal emergence that can be useful in IIT and its theory of consciousness. So quantifying causal emergence shows that macro can feed the micro by Hoel, Albantakis, I'm not sure if I'm pronouncing her name right, and Tononi. In 2013, I'll be going through some of their evidence for this idea of emergence. Okay, so the overview of the talk, I'll be talking about some concepts of emergence in the first part. That's that circle all the way to the left. If you get nothing else from this talk, hopefully you'll get this kind of philosophical benefit of going through some concepts of emergence and thinking about how they might apply to your own work. Then I'll be applying some concepts of emergence to IIT, this PNAS paper. I'll ask the question whether it is consciousness that emerges in that framework, whether that's the best way of understanding that evidence, and then I'll offer an alternative explanation. And like I said, I'll be arguing that consciousness does not emerge, so you have a little bit of a sense of where I'm going. So starting with emergence, I'm hoping that people already have a sense of what emergence is here, and I don't have to go into a lot of detail about the general definition, but the basics are that emergence occurs when there's a whole that's greater than its parts. It's considered to be the opposite of reduction. Most people, when they hear the word emergence, they think of original British emergence, or OG British emergence. This was arguably discovered by John Stuart Mill when he started talking about chemical configuration. So he noted that chemical interactions depend on the specific configuration of the particles. So he thought that that meant that there must be configurational forces that exist at the level of these molecules that don't exist at the level of the individual atoms. Now we can actually explain these effects from the configurations through other means, quantum mechanics. McLaughlin wrote about that in 1992. But at the time of John Stuart Mill, this convinced a lot of people and led to this concept of a layer cake form of reality. Yeah.
Is that McLaughlin, the physicist?
No, Brian McLaughlin, the philosopher at Rutgers. Yeah. Yeah. So yeah, the layer cake picture on the right is to demonstrate this. The idea is that there are some sciences like neuroscience, maybe you can see at the top of the cake, and then biology, and then chemistry and physics And they each have their own domains. And the tricky thing is to figure out how to get the laws to connect these independent domains with their own laws and phenomena. Okay, that's the original form of emergence. That's the form that most people think of when they hear emergence, and what makes people say that they think emergence is unscientific, because they're thinking of this old school view of emergence. And that is also what informs what's currently called strong emergence. Sometimes people call this ontological emergence. The word strong refers to how many metaphysical commitments you're making. So are you saying that this emergent thing exists in reality or not? In strong emergence, you're saying it exists in reality. A really easy to understand example of this would be you take some seeds, you add water and light, and you get a plant. So something new comes out of the seeds, the water, and the light. You might say that the plant emerges from the seeds. That would be a case of diachronic emergence. That is, the emergence of a new thing from other parts over time. That's not the one that philosophers get excited about, for the most part. Philosophers get excited about the possibility of synchronic emergence. That is, do you have a new thing apart from the parts that make it up at the same moment of time? So are the seeds separate from their component atoms? Like, is there something about the seed that goes above and beyond its component atoms? Is it non-reducible to its component atoms? Is the plant non-reducible to its component atoms? That's the question of strong emergence. So you can contrast it with ontological reduction. This is a quote from Evan Thompson's book. In ontological reduction, the relations between the parts of the system are all determined without remainder by the intrinsic properties of the most basic parts. So if you are a strong emergentist, you deny that. If conscious experience were strongly emergent, it would face the interaction problem, the problem faced by dualism. That is, if conscious experience is an emergent thing that the parts are neither necessary nor sufficient for, then you're going to have a hard time explaining how it's related to its parts. And that's the main reason why people consider emergence to be non-scientific. But on the other hand, you hear this language that emergence is ubiquitous. So you'll hear in papers sometimes that it's non-scientific, and sometimes you'll hear that it's ubiquitous. This is taken from a slide presented to the NSF, arguing that the NSF should be focusing much more on emergence. And it was arguing that emergence is ubiquitous. You see it on all these different scales. These are all different imagistic examples of emergent phenomena according to this person. This person was not thinking in terms of strong emergence. They were thinking in terms of complexity science and what's often called weak emergence. Weak emergence is, you could also call epistemic emergence. People use the term strong and weak a little bit different here. It almost always has to do with your metaphysical commitments. How committed are your metaphysics to this emergent entity? And then where they put strong and weak can vary on that scale. But weak emergence is always referring to one that's epistemic to some degree. The idea is here that the emergence happens for our understanding or access rather than reality or metaphysics. So I like to give the example of a cloud, even though some people have argued that certain clouds are emergent in a stronger sense. In this example, I'm just thinking of the shape of a cloud. So it may be that if you look at a cloud in the sky, you think that it is clearly separable from the rest of the sky. Whereas if you were to zoom in on the cloud, it wouldn't be so clearly separable. The droplets are just kind of there in the sky, right? Like if you fly through a cloud. So the shape might disappear as you get closer, as you zoom in. So it appears that the cloud is somehow distinct from the sky in a stronger sense than it actually is if you zoom in. But that's just an appearance. So that might be a case of a weak emergence, but it's not a case of any kind of ontological emergence. There's no thing, the cloud, that's separate from its parts. It's just the appearance of a shape. If consciousness were only weakly emergent, then it would just be a way that we describe the underlying phenomena. All right, so most people working on emergence are in between weak and strong emergence. Most people, especially who are working on whether consciousness, the self, all these things are emergent, they're thinking in terms of in-between forms. The most popular form in philosophy is called supervenience. This has been talked about for about 50 years or more. This is in between weak and strong because you could see weak as the case in which the parts would be necessary and sufficient for the emergent entity, and strong is the case in which the parts are neither necessary nor sufficient for the emergent entity. In supervenience, the parts are sufficient but not necessary. So the parts have a connection to the whole, but they don't dictate the whole. There's something about the emergent entity that goes beyond the parts. One reason that you might be interested in supervenience is because of multiple realizability, which has already come up in this conference. So to illustrate this idea of the parts being sufficient but not necessary, the parts of the octopus brain that are related to pain, those parts might be sufficient to bring about the pain of the octopus, but they're not necessary for pain. You could have different parts in the human brain bring about the same pain. So that's what it means to be sufficient but not necessary. You can have different parts for the same pain. But once you have the parts, that's sufficient to bring about the pain. A problem with supervenience, as used to argue for emergent consciousness, was brought up by Jaegwon Kim in the 90s, which is that, as he argued, supervenience theorists will not be able to establish independent causal power for that emergent entity. And so, according to some accounts, that means that entity wouldn't have independent existence. So that's kind of an existing problem that IIT is walking into. Just to give you a little preview, this paper from the IIT group is arguing for a supervenience account that does give causal power to the emergent thing. So it aims to solve this problem. The final version of emergence that I wanted to talk about is called contextual emergence. It's the twin sister of supervenience. It's gotten a lot less airtime. It's a more recently discussed topic.
Are you talking about the Albantakis paper?
Yeah.
Do they actually use the word supervenience in that? Oh.
Yeah. I'll show you a quote. Contextual emergence, arguably discovered by Hoel, Albantakis. The idea here is that the parts are necessary but not sufficient for the whole. So the context plays a crucial role in whether or not the whole emerges from the parts. He gives the example of temperature, that if the relationship between motion in electrons and heat, that relationship depends on thermodynamic equilibrium, so it depends on nearby thermal bodies. So that's the context in which that relationship emerges, he argues. So this little chart at the bottom right is trying to give a sense of what this might look like. You have these contextual constraints pushing from above, and you have these shapes at the bottom, and they're kind of changing over time in response to the constraints or the context. And so the relationship between these parts emerges due to the context. That's the basic idea. So again, this is the reverse of supervenience. You still have a relationship to the parts, but it's a different relationship than supervenience. And in my view, this is the more interesting form of emergence to be used, in my case, for the existence of the subject.
Can we read about the temperature? What was the example?
The idea is that the relationship between electron motion and temperature, that depends on the zeroth law of thermodynamics, that there's thermodynamic equilibrium, and that is the context in which that relationship emerges. So you can't, that law about that relating those two is not a law without that external assumption, without that context. That's Albantakis' argument, yeah. Okay, so that's background on emergence. Now I'm going to connect a little bit with IIT. I said that I'd be talking about this 2013 paper, which is true, but I will also mention briefly at the end this 2016 paper, and that's because the 2013 paper doesn't make a strong connection to consciousness. The 2016 paper does a little bit more on that. So this is a quote from the 2016 paper. In this article, we address the issue of causal emergence and question the micro-assumption about causal power by resorting to the theoretical framework provided by integrated information theory. It's a theory of consciousness, etc. So we make the link between the two papers there. All right, I don't think I need to review IIT. I think we've done enough here. IIT is a theory that consciousness is integrated information. Okay, PNAS paper. So in this 2013 paper, the authors are arguing that they can establish emergence, that is the emergence of something at the macro level that has its own causal power. Here's a quote from the paper. we show that for certain causal architectures, effective information can peak at a macro level. So you have effective information emerging at the macro level. This happens when coarse-grained macro mechanisms are more effective, that is more deterministic and less degenerate, I'll describe that in a second, than the underlying micromechanisms. Thus, although the macro level supervenes on the micro, there's your supervenience, it can supersede it causally, leading to genuine causal emergence. I'm going to go through this again. This is kind of the overview, and then I'm going to give you the parts that hopefully will clarify these claims. So this is not a math talk. This is a criticism of a math paper, but I have to have like a little bit of like diagrams for that. So what do they mean by non-deterministic and not degenerate? So in this case, these three authors are looking at a closed system, and they're wondering if they define cause and effect a certain way in this closed system, when can they identify the cause-effect pair relative to the rest of the system? A completely noisy system would be one in which every single cause is related to every single effect. So you're not going to be able to tell when you have 11 as an effect, as you can see in the middle, hopefully there, you're not going to be able to tell which of the other things could have caused it because they're all completely interrelated. That's a completely noisy system. A completely degenerate system in this paper is one in which all of the causes lead to the same effect. And similarly, you don't have as much effective information in that case for identifying causal power because it's difficult to differentiate which of the causes could have led to that effect. So the causally perfect system for them is the one in which there is a single pair between cause and effect. So it's going to be really easy to isolate which thing is doing the causing. So the information comes from the amount of binary whatever, and then the effectiveness comes from the lack of noisiness and degeneracy. This image from their paper illustrates the difference between the micro level and the macro level for them. So this is again a closed system. The micro level, this is a toy example that they have in their paper, has just these 4 elements. The macro level has 2 elements. So they've grouped together some of the micro elements to get the macro elements, and they've looked at how those now pseudo-macro elements interact. And they want to know which of these has more effective information, that is, you can identify the causal connections between them. So it has to have a lot of information, which the micro level has more of because it has more elements, but it has to be effective information. You don't want degeneracy or noisiness. And what they found is that the noisiness can reduce enough to make up for the lack of information at the macro level. And so it can make the macro level be the level at which you would want to say causal power is happening. And they explicitly connect it to neuroscience. So the final toy example I'm giving here is they talk about these nodes at the bottom as taking the place of neurons and the neural connections between them. And they talk about how the neurons might group together. And so when they are saying that it's possible to have emergent causal power, they think that that could be in the brain specifically. So they think it could be that if you look at the level of neurons in the brain, you're going to have less effective information than if you look at the level of groups of neurons, depending on the specific architecture of the neural system. Okay, so they show that for certain causal architectures, effective information can peak at the macro level. That happens when the coarse-grained macro mechanisms are more effective, that is more deterministic and less degenerate than the underlying micro mechanisms. Thus, although the macro level supervenes on the micro, and what that means is that you get the macro just from the micro. Remember, the parts are sufficient for the macro. So you don't need anything but the parts to get those macro elements. It's a closed system, supervenes on it. Nonetheless, the macro can supersede it causally. That is, you can have more effective information about causation at the macro level than at the micro level, leading to genuine causal emergence. That's our point. Okay, this is consciousness. So I will just skip this. So supervenience I already said that it's connected to this concept of supervenience. They explicitly use the concept of supervenience in their paper. They want to say the macroentities supervene in the microentities. It also uses the concept of causal emergence. The macroentities make more of an impact on the system than the microentities, using this notion of effective information. But you might be asking, can this help to explain consciousness? One reason to assume that is because of the authors of the paper, that these are people who have been responsible for an integrated information theory of consciousness. It's talking about information. The later paper in 2016 makes a more explicit link to consciousness, but that later paper isn't as exact as that. It says these results are relevant to a theoretical account of consciousness because for integrated information theory, the spatiotemporal maximum of integrated information fixes the spatiotemporal scale of consciousness. So they take that earlier paper to establish the spatiotemporal scale of consciousness, but they don't say that what they discovered is an emergent consciousness. More reason to think that they're thinking of this thing as consciousness is that the end of this quote says, more generally, these results showed the notions of macro-causal emergence and micro-causal exclusion hold when causal power is assessed in full and from the intrinsic perspective of a system. That's how they talk usually when they're talking about consciousness, this intrinsic perspective of the system. So I think it's reasonable to interpret these papers as being about consciousness. I did happen to mention to Tononi at the beginning of this conference, Giulio, that I was going to be arguing that consciousness does not emerge, and he says he agrees. So I don't know what our difference is on this, but I'll just keep going. So if you think that that paper is about consciousness emerging, I'm going to try to argue that it doesn't emerge. And I'm going to give two very basic reasons why I think that consciousness does not emerge. One is what I call facial improbability. This is a general point. It's not about IIT. I actually think this applies to lots of papers that rely on this concept of emergence to try to explain consciousness. If you're trying to use emergence to explain consciousness, to solve the problem of consciousness, and you're not doing other work, that's where my objection comes in. So the idea here is that the search for theories and models of consciousness is a search for something that would explain the special qualities of consciousness, subjectivity, for example. But emergence only provides greater scale. So it's facially improbable that scale alone is going to render the special qualities of consciousness. Does that mean 5 minutes? Cool. So this point is just that if you're trying to use emergence to do the work of getting you the specialness of consciousness, that's not probable. That's not likely that you're going to get there with that move. That doesn't mean that emergence can't do something in the explanation, but you're not going to get there alone. So you might think that maybe emergence plus transformation. So if you have an emergent thing and that emergence somehow transforms, the properties of the parts into something new, then now you've explained consciousness. But then note that the transformation is the interesting thing for answering the problem of consciousness. So I don't think emergence is likely the right place to look if you're interested in naturalized theory of consciousness. With respect to IIT specifically, I think this is an overly subjective analysis. So as I see it, consciousness is porous. We both observe consciousness in others. I'm not saying we have perfect observation skills, but we note that there is consciousness in others. It's something when we see that they're acting, that they have an action rather than a reflex, that's a nod to their consciousness. And then also our consciousness is impacted by forces external to it. So an isolated system isn't the right approach, I think, if you're going to explain consciousness, because it just is porous. It's more of an open system rather than a closed system. So already I'm a little skeptical whether it's going to be able to do the work that we need for a model of consciousness. But then in this case, they've argued for causal power from the perspective of the system. And unless if consciousness is the thing that emerges, and we only think it has causal power from the perspective of itself, I don't think that fits the way we think about consciousness. We think about consciousness having causal power from the outside, not just from the perspective of the system itself. So they've made a case for causal power from the system's perspective, and I think we would want something more from a model of consciousness. Okay, so an alternative that I'm going to explain in a couple of minutes, and this was never going to be satisfying because it's just too short of a talk to do this. But here's a brief take on what my own view on this problem is. So I think that we've been too focused on consciousness as an object, something that might emerge. If anybody was at Anna's talk earlier, she was making a very similar case. So I think of consciousness as deeply unstable in flux, changing with the environment, changing with attention, etc. But subjects and worlds are much more stable. There's nothing that's perfectly stable. Everything is in flux, but some things are more in flux. And those things are just not great candidates for objectivity, I think. And consciousness is one of those things. So my suggestion is that we should see subjects and their worlds as emerging rather than consciousness as emerging. In my view, we can solve the problem of consciousness by determining exactly what the subject is, what the world is, and how the two are related. That is, I see consciousness as a relation between subjects and their world, so we want to refocus analysis on that relation, which does not itself emerge. I'm happy to answer questions on why it doesn't emerge. There is an argument behind that. But to just close up the talk, the alternative explanation that I would offer of the model that Tononi and colleagues present is that instead of seeing it as a closed system that applies just to the brain, let's say, that you could see that same system as actually being, the entire physical system, the entire universe, and then the things that are emerging in it would be the macro subjects. So that would be consistent with the way that I'm thinking about it. But even if we were to take those elements of the model and try to apply them to my way of thinking about it, it would still be missing porousness. So you'd still want to add to the model something that would allow for this boundary, a boundary between the subjects and their world that can be crossed. I think you can do that through contextual emergence and self-organization. That's a case that has been made also by other people, but that's something that I'm interested in working on further. Okay, so these are some books that I have if you're interested in attention. I have a book called The Attending Mind, where I argued for the emergence of a subject from 2020. This is an edited volume in the middle, so it has lots of short chapters connecting philosophy and neuroscience if you're interested in kind of getting a look at what contemporary philosophers of neuroscience are doing. And then the final one is a forthcoming volume on attention and mental control.
Great, thank you.